In this presentation, I will introduce the idea of ubiquitous computing. What exactly is ubiquitous computing? To answer this question, let's go back into the distant past. And by distant past, I mean the 1950s, the 1960s, the 1970s. This is the age of mainframe computers. Mainframes were machines that could speed up calculations at rates that were astonishing for those days. Here's an IBM advertisement that tells us that having a mainframe is like having an extra 150 engineers on staff. Mainframes were expensive, and one such expensive computer was used by many users. As for the human-computer interaction, it required users to fully focus on the computer. They had to write programs, load them, for example, using punch cards, and collect the printed output. Also, human-computer interaction for mainframes required extensive training. First of all, computers were used to solve engineering and scientific problems, so the topic of interaction already required training. Programming, punch cards, printing results, these all required further training. Users needed to know commands, arguments, and buttons to press. Mainframes were also usually not connected to a network, or at least nothing like today's World Wide Web. Rather, their work was confined to a particular organization, such as a company. After this distant past came a more recent past, the era of personal computers. Starting with the 1970s, PCs of all sorts made advances. IBM, Commodore, Apple, Sinclair ZX80. These are some of the computers that entered our homes. The prevalent interaction mode became one computer, one user. Interactions still required a complete focus of attention on the screen and keyboard, and this interaction still required significant training. However, the ranks of computer users were increasing as computers started to be used for many purposes accessible to a wider population: word processing, games, and art. Of course, PCs were not always connected to the network. In the beginning, data was often stored on cassette tapes and later floppy disks. PCs only slowly became the access points to the World Wide Web that they are today. And that brings us to the present. PCs are still here, but computation is moving away from them. We might have a PC, a desktop, or a laptop, or both, but we have other devices, such as mobile phones, tablets, and streaming devices, and soon we will have a number of wearable devices too. These could include Google Glass or Apple's iWatch, just to name a couple. We have already moved into this ubiquitous computing era in which one user has many computing devices. Of course, ubiquitous computing is clearly connected computing. All of the devices we can think of today are connected. If we don't have a connection to the internet, we are distressed. Ubicom is connected computing. Ubiquitous computing is a multidisciplinary field. Major areas of work within Ubicom include embedded computing, networking, and my primary interest, which is human-computer interaction. Human-computer interaction is critical because you cannot simply take the complex interactions of the past and implement them on a mobile platform to be used by pretty much everybody. Instead, you have to create natural interactions that are intuitive. Let me now turn to a couple of exciting developments within human-computer interaction for ubiquitous computing. First, many companies are making a push into the personal health arena. Within personal health, we can see devices such as the Microsoft Band in this image. These devices collect data such as heart rate and the number of paces taken during a workout, and they provide feedback relative to your health goals, such as how much energy you've used and where you stand with respect to your weekly goals. But they also let you access your email, and not because that's healthy, but because users want to be connected all the time. Small devices such as the Microsoft Band are an excellent example of the progress we've made with novel user interactions. After all, how do you interact with a tiny device like this and do so while you're working out? Typing on a keyboard is out of the question. There is no keyboard. So we now have touch interaction to interact with the small display, gestures to interact, to initiate actions, and speech to issue commands and receive feedback. Another exciting arena for novel interactions is in vehicles. Here we see the advent of programmable displays. The displays can adapt to context. When reversing, the display can be used to show a view from a rear-facing camera. When stopped, It can help us determine which doors are open, and when underway, it might display navigation information. It is also important to explore how these programmable displays could distract the driver. A lot of the effort in the field of in-vehicle user interfaces focuses on this question. So, this is ubiquitous computing. It is our era of computing where one user interacts with many networked computing devices. Our future is exciting. We're beginning to see more and more of these computing devices connected to sensors and actuators. For example, I recently purchased a device that tells me when to water a plant. I placed it in a flower pot, it measures moisture in the soil, and it sends me alerts when it's time to water the plant. That's convenient. We are also beginning to see novel user interactions, and I expect that these will change in dramatic ways. After all, with all of the sensors and actuators we will have access to, we will have more data than ever before in history. The new user interfaces will allow us to take advantage of all this data without being utterly overwhelmed. And finally, with computing becoming such an integral part of our lives, our future will have to include some very serious protections for privacy and data security. I don't want to worry about someone stealing my payment codes from my wearable gadget as I'm using it to pay for my coffee. I have to be able to trust that this will not happen, or at least that it will not happen very often. So this is where ubiquitous computing has to go next, and it has to become the intuitive and trustworthy computing fabric of our lives.